The average velocity is defined as the displacement over time. So you might remember that delta x is the symbol for displacement. It means change in position, and we're dividing by delta t, the time interval that matches the displacement interval. I have two different ways of writing it up here. I use velocity, the velocity vector symbol, with AVE for average as a subscript. A lot of books will use a velocity with a bar over the top. The reason I don't like that, it is very common to use a bar over the top to mean average. The reason I don't like that is that when you get to 3D, you're dropping the vector symbol and putting a vector and then a bar over the top of that just seems like overkill to me. So I usually write it like this to avoid that problem. And then, like I said, it's displacement over time. Oh, it is a vector because position is a vector. And so when you're taking a vector and dividing by a scalar, you can just get back a vector. And it has units of meters per second in the standard MKS system. So it's a vector and it has units of meters per second. Vector, of course, means that the direction will matter. We can do several quick examples. One of my favorites is to do the position, do t squared. If I make a table of values for that, I'll put t first, and then x. When time is 0, x is 0. Oh, I want x to position to be in meters, time to be in seconds. So when time is 1 second, then 1 squared is 1. But when t is 2 seconds, you'll get 4 meters. And when it's 3, you'll get 9 meters. And when it's 4, you'll get 16 meters. That's a nice set to do. And now I can ask, what is the average velocity from t equals 0, t equals 3 seconds? So what is the average velocity over that window? So average velocity is just the delta x over delta t. The delta x is going to be the x value at 3 seconds. There's a lot of ways to write that. I'm going to write it as a subscript, and I went to 0. And then on the bottom, it's just the delta time is just the final time minus the initial time is just the 3 minus the 0. I can look over on my table to find out that when t equals 3, x equals 9. And when t equals 0, x equals 0. So I get 9 minus 0 meters over 3 minus 0 in seconds. So I get 3 meters per second. 3 meters per second for that one.